All right, is it live? I'm trying out something new today. Oh, I got the notification on my phone. I think we're good. I'm switching to something called OBS. Usually I run these off of Zoom, but I'm doing OBS today. So my setup looks a lot more like this. And yeah, I'm gonna give it like 15 minutes for people to join as usual. I might get started a little bit earlier. I don't even know how to mute myself. I usually mute myself at the start of these for like 15 minutes. I'm able to like write directly over top of the screen to like the Twitch streamers you've seen I've done. I might dual stream to Twitch next week if I can get the hang of this by then. Geez, I think it like froze up on me. I can't. Maybe I could just do. Jeez, are you kidding me? There we go. Okay. Yeah, I obviously do not have the hang of watching it live. So like I realize that I'm doing this at a really inconvenient time for most people that are on the East Coast or Europe, or I even have a friend that's in London, and it's like it's a really inconvenient time for anybody outside of like the Pacific Coast in India. And so it'd be great if I could actually make this at a much more convenient time. So that's what I'm trying out. It's maybe going to be a little bit more convenient here. On some videos and have posted my inquiries in Discord. I usually get back on Saturdays. It's just that usually I don't even wake up until like an hour or two from now. I will get back to questions here after this first stream for today. I got a second one at 3 p.m., but I'll be getting back before the first one. I usually start replying to stuff like once a week on Saturdays around 10 or 11 a.m. I'm trying to figure out how to change the size of the text on OBS so I can show the message I usually do. I didn't even change the image I usually show for the proper time. But yeah, I do get back. I try to get back to every single thing that I'm pinged about on Discord. I don't get back to my YouTube comments. I don't get back to my YouTube comments. That's true. I don't really make a lot of effort there, but for the Discord comments, I do make a solid effort to get back to every single thing that has my name tagged on it. I do take a while to get back to it. It'll take up to a week usually because I do like a weekly clear out on Saturdays. I have a full-time job, of course, and it's I put in a lot of hours for it, so I don't really get back on Monday through Friday typically. But Saturdays, I usually do a clear out of the whole thing. All right, we're going to try... There. All right, it's kind of working. This is kind of working. There we go. There we go. If only I can make the background stand out more. I know how to do this. I think I figured out this thing. What's making today also interesting is that again, there's the new tool that I'm trying out, and it's you know what? I could just show this over here. That's what I'm trying to get the chat box in the little corner, like the Twitch streamers do. I did get one tool to kind of work. It's here, I'll show you. It's really botched. I got to remove the one in the middle, but we're gonna have that overlay for the afternoon when I get it working. For DB to DB replication, here I'm just gonna go ahead and throw this over here. There, this will be our overlay for today. I think that's what we'll do. We'll just use this for our overlay instead of having something a little bit more nice looking. For DB to DB replication in real time, there are a couple of approaches you have discussed. Oh, like the change data capture. Yeah, change data capture. Let me just pros and cons of each with respect to cap, cost, etc. I have kind of made a little video about it. It was really old. But so with change data capture, if you're using the DB triggers approach, usually you will have Kafka involved. I found out in last week's stream that Debezium actually does use Kafka under the hood, was what somebody claimed. But for that, where you're using the DB trigger, it's going to be eventual consistency. While with read replicas, they're also, at least with like DynamoDB, they are also going to have eventual consistency. So you're not going to get strong consistency most of the time unless you make the replicas synchronous. Or you're doing, or it's a leaderless database, you're doing strict quorums on it, then you'll also get strong read consistency. Yeah, I would. It's really hard to get into that stuff, though. It is kind of hard to find information on it. There's like a really strict divide between like the really hard theory content, and then for the applied problems, there's not really anybody out there that's actually seems to really know what they're talking about for anything involving consensus, causal consistency, sequential consistency, anything like that. I do actually try to talk about it. It's rare that you have problems actually can apply it. Online auction this afternoon is actually going to be one case where you can talk about one of the really tricky use cases, because it's one of the cases where you can kind of talk about the difference between whether sequential consistency is good enough or you actually need to go all the way with linearizability. So yeah, I can, nobody actually, I've never seen anybody else mention anything like that though. So it is hard to find this stuff. Yeah, most of the stuff for DB replication, though, getting back to your main question, most stuff for DB replication, though, is going to be eventual consistency, so it's more on the side of higher availability than stronger consistency. You can get strong read consistency with DynamoDB as well, and I believe that the way that it works is that it actually does the reads against the leader nodes. So then, of course, you're going to get the same exact data as what you have from your writes. It's very easy to get read your writes consistency with that. I'm going to try and see if there's some better way to format this thing. So this only seems to like fix like the bottom half. I can't tell what the heck this actually changes with it. Yeah, it only changes the bottom half of it. I'll stop fiddling with it. We were looking to replicate from Redis to Postgres via. So Redis to Postgres is a really interesting choice because Redis is not persistent, while Postgres has much better durability. And so I think usually you'd want to go from Postgres to Redis. I was thinking that you might actually want to do a write to Postgres first and then use a trigger to replicate it over to Redis instead. Because Postgres would have better durability, but if you're looking for really fast reads, you would want to have the reads actually off of Redis. What you're saying though with Redis to Postgres, I guess you could call that a write through cache. So in Don Martin's system design primer, he went through all these different caching strategies. And like you usually don't really think about the names of them, like write aside or write through or write back or refresh ahead. You don't usually think about those when you're looking at the higher level designs and the stuff that you see in like Alex Shu's books. But like with your example of Redis to Postgres, I would maybe call that a write through. There might perhaps be some cases where it makes sense. But that's generally not really something that I've heard of a whole lot. Usually you do want to hit the, even internally within a database, they actually have this thing called a write ahead log, commonly abbreviated as WAL, which is actually, it's this log file on disk. And so before it updates any of the secondary indexes, like the B tree or LSM tree or any of the indexing stuff for the reads, the very first thing that it does is write to this log, and then it's like, okay, I'm now freed up to return a 200 success status to the caller to the database. It's like, okay, it's on the write ahead log, and then it has this really cool process called ARIES, ARIES, ARIES for recovery, which is that as soon as you get on the write ahead log, it's like it's in the database. It's like there. You can go ahead and do a power cycle and it'll be able to recover and put that, and it'll be able to get whatever the heck you got onto that write ahead log all the way through the indexes and drive it through the rest of the database as long as it's in that write ahead log. So it's like even on the DB level, it cares about the durability very like first and foremost. While with Redis, since it's a RAM thing, it's typically used entirely through RAM. There are ways to persist it and make it more durable now, but like the primary use case of Redis is a cache, and so you wouldn't typically have that durability component. You wouldn't be writing anything to disk. All right, I think we're at 9:15. We can go ahead and get started. I'm going to have a better overlay this afternoon for the chat, but I think I'm just going to go ahead and leave this here. And this can be what we use throughout the session. Why is it? Okay, there we go. Problem, we chose Redis first with Redis replication since we were okay to lose. Okay, if you're okay with losing any data at all, then yeah, I guess it's fine to go ahead and do the write through. That is one of the rare use cases where it's okay to put Redis in front of Postgres instead of vice versa. So yeah, I mean, it's usually you're not okay with any data loss at all, is why you usually have Postgres in the front. Okay. If you ask that on Discord, by the way, I will be getting back to that after this first session. I usually do my weekly sweep through all of the Discord pings on Saturdays. I usually just don't get up for another hour. All right, I think we're good to get started. Yeah, so today we're going to be doing... Oh, that's why I can't have that on there. Okay. That was why I can't use that as my overlay on the chat. I know what to do, though. I know what to do here. I think this one will actually stick when I switch to something else, but it looks weird. This will work, and we'll have a nicer overlay this afternoon. Okay. Anyways, today we're going to be covering the hypersonic missile problem. It actually has been asked as a Google interview question. I'll get back to any more comments in the chat here in a couple of minutes after I've done a little bit more introduction of this problem. So like I said, hypersonic missile problem. I've heard it's an actual Google interview question. In order to try and get a little bit of background on this, I did read about, there actually was a little bit of coverage on GPS over in Distributed Systems by Tannenbaum and von Steen. It was literally like 1 or 2 pages out of like the 500 in the book, though. It was still worth it to scrape any information that I could about how GPS works. I imagine Wikipedia probably had more information than Tannenbaum had, but I didn't actually read through the Wikipedia page. I probably should have done that a little more. I think DDIA actually did bring up there's a potential for the Byzantine Generals problem on this, which is where you have some processors that don't actually trust each other, and it's because of the extreme temperature that you can put the CPUs through. I can go ahead and just start drawing this out for fun. Okay, let's go ahead and have the missile. It's not a browser, it's a missile. It's going to have this missile that it's the device, kind of like a phone or a computer or a smart fridge, or like with the vending machines problem, you had like a vending machine as your device. So this is kind of like the vending machine device from the vending machines problem that I did many months ago. We're going to treat it like that. We're also going to go ahead and have, actually, I think we can just go ahead and have it as brown. It's not quite, we might, I don't know whether to kind of treat this more as like a client or just a back-end service. I guess it doesn't even really matter a whole lot. Yeah, so, and then we're going to have a couple of GPS satellites. I'm going to go ahead and draw out a couple. So we're going to have 1, 2. I heard that usually 4 satellites are involved in establishing an XYZ location for a device. So we're going to have 4 like this. I think it mentioned like 72 satellites or something are involved in GPS. It's, I don't know, the book's old. Yeah. So anyways, it's not, I wouldn't say GPS is quite horizontally scaled out. You literally do need 4 unique satellites in order to establish like a 3-dimensional location of a thing. And it does need to be 3-dimensional rather than 2-dimensional because it's latitude, longitude, and altitude. And I heard they just kind of like broadcast information over to the missile. What's really fascinating is that the GPS satellites are using atomic clocks. You might have heard of atomic clocks before from Spanner, which uses atomic clocks. Which means that the GPS satellites actually have a really accurate time on them, but our missile is traveling at supersonic speeds, which means that they're going to get really small amounts of time distortion as well from general relativity, which I heard is an issue with satellites, is that they actually do get a little bit of time flux from general relativity. So I guess I don't know if the atomic clocks are even going to be all that good in our use case of the missile. But yeah, so that's kind of how the location broadcasting part works, is that it's kind of like this triangulation thing that you use, and there's going to be a time delta for the amount of time that takes to get from the GPS with its atomic clock to your missile. I don't know if your missile is going to also have an atomic clock on it as well. So that's going to be interesting. Maybe you can just use the timestamps from the 4 satellites and compare those, and you don't actually need your local time as much, hopefully. So that's one component of it. And then, like I said, so you're going to kind of have some kind of CPU on here for figuring out its own location and where it needs to go to, and kind of like calculate the kind of adjustments that it needs to make for like the speed. It's special. Yeah, you're probably right. You're probably right. Yeah, I'm not. This is one of the rare cases where you might get a little bit more physics with this, and not a lot of stuff involves these nice, very fascinating, like general relativity, special relativity, atomic clock stuff. But this is one of them, so it's really fascinating. And then, like I said, I really want to talk about the Byzantine Generals problem, because it's also another thing that's really, really rare on top of the special relativity thing. So you're going to have, you of course have like the CPU. I'm going to go ahead and use the special component, even though it's not exactly anything special about it relative to a server, but it's like you actually have to kind of consider the CPU specifically in this case. So you're going to have maybe like a couple of CPUs somehow involved in the missile for some different subsystems on it. And the reason why the Byzantine Generals problem applies here is that those chips are going to be operating in really different environments than what you'd have in a server room. The ones in a cloud data center they're going to be under a little bit of strain, and I mean they are going to be rather hot, maybe at like a couple hundred Fahrenheit. But these ones are in a missile going through the atmosphere, and so they might actually be at like much higher temperatures than just when they're running at 100% CPU utilization. And that's actually, I did work at a defense contractor briefly, and they actually have a concern over counterfeit CPU parts, which is very fascinating, because the parts actually, when you run the digital signals through them, it looks right. What's wrong and why it's concerned that they're counterfeit is that these counterfeits are of a lower quality, and so then when they hit those temperature thresholds that the legitimate chips from Samsung or whatever are intended to be able to operate under, like 500 Fahrenheit or whatever, the counterfeit ones are actually going to break down at much lower temperatures than the legitimate ones that are giving an SLA of like 500 degrees Fahrenheit or whatever. They'll break at like 300, and then you have your rocket running at 400 degrees, and the chip melts. So Byzantine Generals problem, maybe this chip's going to melt and this one's not. Another case is that the Wall Street Journal actually, I read this article about the Ukraine war where some of the missiles that we're giving them, maybe it's the Tomahawk missiles, actually use they actually use GPS and geographic imagery. I mentioned that this is a broadcast, which means that if there's no handshake performed and it's just one way, you could probably impersonate the GPS. You could probably impersonate it and give it fake data. So what I've heard is that if the missile thinks that the GPS location doesn't make sense for the Tomahawk missiles, it'll actually switch over to these onboard cameras that are like looking at geographic imagery of where it's at in order to more accurately figure out its own location. So it actually doesn't even trust the data coming from the GPS. And so you do actually have a case of the Byzantine Generals problem kind of occurring there, I believe. But it's a rare instance where the CPUs actually might not trust each other. which is really fascinating, very, very rare. And so one of the suggested approaches to solving the Byzantine Generals is, of course, I believe it's the blockchain, where you have this zero trust system and you do this like very labor intensive thing of the mining process, and you use proof of work in order to prove that you have the right solution or whatever. You're obviously not going to be running a blockchain on a missile, but that is one thing that I believe is being done about the Byzantine Generals problem. You can't do that here. But I did want to call out that problem because I do believe it applies here. I think it was even brought up in DDIA for aerospace devices somehow. Anyways, that's a little bit more context on that. I believe there's a couple of other things I want to go into for this, such as you're going to want to calculate your own speed off the GPS satellites. I don't think it's like how else you're going to figure out how fast it's going and whether the trajectory is right, is that you're probably going to want to log the location over time. And so you're going to log that, and then you're also probably going to know if you'll probably want to know if your missile actually hit its target or not. And so you're probably actually even going to have some kind of missile tracking service. And I don't think anything here is going to be using TCP connections with a proper handshake, since it's going at such a fast pace, and it's probably going to look a lot more like what you would see in the stock exchange problem. Let me even add that as a resource, as the stock exchange problem, which is using UDP broadcasts of stock prices, because it's like if one packet gets missed, you can even rebroadcast your last 5 data points every single time, possibly over to the missile tracking service. And you just rebroadcast it several times, and you just don't even care about a response back. So it's just a one-way broadcast over there with like UDP. So I think like everything here is probably going to be using something that looks like UDP. I'm going to get to the comments in the chat next, now that I've kind of given a draft of how all this is probably going to look. I'm probably not going to have a whole bunch of different approaches unless there's some guidance in the chat. I was actually a little stumped with all that much creative stuff that I can do with this problem for once. Yeah, let me get through the comments here. I think that was from the thing from earlier. Can we discuss the cost part while discussing trade-offs if possible? I had some information about cost in the README of the Discord group. I know that I haven't gotten to that a lot. So you actually won't usually talk about cost in a system design interview. That is actually something that I was really interested in getting into as I start to do some revisits of some of the problems. One of my goals is actually to find like an exact cutoff for the value at which you would consider somebody a celebrity on Twitter. And so you'd prefer to cache their tweets and just go ahead and have them pulled like Elon Musk's rather than having it fanned out. But that's going to require some really hard math that you would never do in an actual interview. So cost estimates, I don't think those even are typically done in staff level interviews. I think those would be fun though, because I'm not doing these like real interview questions. I'm going deeper than that and treating them more as case studies and going unrealistically deep in them, which I think is what makes this more fun and exciting than what people usually do. I don't like the one approach things that most people do. And staff, and there's a couple staff engineers that also like that. I'm doing multiple approaches and probably going a little bit deeper than this than is normally realistic. So I do want to do that in the future. I don't think I can do that with this problem, but I want to do that with some future problems. That would be really fun. Yeah, that would be sweet. I actually even want to try and start writing some of these problems in like Kubernetes, so that way I can just kind of like spin them up and go ahead and do some stress testing with like JMeter or something in AWS, and like I can even like show like, hey, scatter gather is going to break in this case because it's at like 200,000 TPS or whatever, it will break this thing. Maybe I won't actually throw 200,000 TPS at something, but there are ways to show that scatter gather won't actually scale. So I want to do that kind of stuff start doing some like Kubernetes implementations or something for fun. Prod implementation, it will be a no for many smaller startups. Well, so like the thing with DynamoDB is that you just provision the RPUs and the WPUs, or maybe it's WCUs or something. It's DynamoDB can scale up or down in terms of cost. You can actually have it at on the team that I was at in Amazon, it was actually just astronomically high how much we were spending on DynamoDB, but we might have been doing something really stupid. I think we were maybe doing scatter gather or something. Yeah, that would be interesting though. That would be that I can see how that would be really interesting. And thanks again for the call out on special relativity. Network connections won't be easy, so compressor service is a must along with encoders to code it like enums and converted messages. On this, yeah, I think so. I think yeah, you're probably not going to want to have like full words getting sent over. You're probably going to want to encode something locally and send it over. I actually have watched a couple of videos on how like a Milwaukee, it's called an angle grinder from like Milwaukee. So it's a hardware tool and it has its own special protocols for how the components of the device communicate with each other over these like little enums, kind of like special custom. It's like they rolled their own HTTP protocol. It's really fascinating. They like don't actually use HTTP or like an IP thing. It's something lower level than IP or possibly even Ethernet. And so that like yeah, that's probably the kind of thing that they're going to be doing with the communication between the missile and the missile tracking service. It's not gonna. I don't think it's really gonna even be. It probably won't even be UDP. It's probably gonna be something way more custom and low level than that. It'll be fascinating. It might just use analog radio frequencies or something. I have no idea. It'll probably be about as compressed as you can possibly make it. You did an interview, but I am using this channel for real work. So that is what I'm interested in. Is I actually do kind of want to treat this a little bit as real work and go deeper than what you would normally see in an interview. I want to treat this a little bit more legitimately and talk about like implementing stuff for real. Leaderboard is fascinating. I don't know if anybody would actually do what Alex Shu suggested with the sorted set thing. Like if you are actually trying to do a lookup of whatever is at rank 10,000, yeah, scatter gather is going to suck. I've seen that in practice too. I have seen that like when you do pagination over anything and you like allow the users to go all the way over to page 100. So like even in Google search results, if you're looking at the search results for, here, I'll do, so if you even just have like this and you like go to the bottom, you'll see that there should be, did they get rid of the pagination on Google? When the heck did they do that? Isn't there like page 2, 3, 4? No way. Is it in infinity scroll? There used to be these numbers along the bottom, and so like you could click like page 20 of the search engine results. And so it was like even with Google, you would be able to click to like page 100. Well, unless you're doing something really clever, that would be a scatter gather of like thousands of records, and that would be. It's like I don't think they're just doing scatter gather, but I also don't think that they're actually going to do partitioning by the rank, because then that would work out really weird. If they're inserting records right in the middle, they'd have to re-index, they'd have to re-rank, thousands of records whenever they do some writes into the search engine table. And so like it's like that's unrealistic, but I don't think anyone actually does use a sorted set in practice, but it would make the most sense from what I've read. Unit cost is higher than provisioned Redis, and so like yeah, if you're only dealing with like 10,000 TPS at most, just go with like Postgres, like a single Postgres setup, like on a single EC2 instance. You could, I don't even know if you want RDS. You're good. This is interesting. It's probably going to be a short problem today too. So I've actually seen cases where people do provision PostgreSQL on an EC2 instance at a FAANG company, and it's like weird to see that when like there's also RDS, which will handle automatic backups for you, but like they just have an EC2 instance and they provisioned PostgreSQL onto the one EC2 instance. And I mean, after seeing how Dynamo is set up at Amazon and the team that I was on, and it was wildly expensive, I guess it does kind of like, it's like, how does that even happen? How does it even happen that it's like $1 million a year or whatever? It was, yeah, I can kind of see that with startups. Okay, so I can kind of talk about the logging a little bit more. So we got all these things that are getting broadcast to the missile, and then it has to calculate its own location. Let's say that it's kind of doing some kind of logging, and it's going to be broadcasting this information back. It's going to need to know the history of its own previous data points in order to calculate its current speed. So we can go ahead and do, let's talk about how these onboard logs might kind of look. So it might need to know its own, it's probably going to want to send a missile ID over to the missile tracking service as it's given in its logs. So it's probably not going to have this on its own logs, but it's probably going to have some kind of missile ID just kind of tracked internally, like a device ID. It's probably going to have a timestamp. We'll have latitude and longitude. You'll probably have altitude. It's in a three-dimensional space, so you have latitude and longitude is like where it's at, but it also might be ascending or descending upwards like an airplane. And when you're trying to get like really good precision of exactly where it's going to hit, it probably would be a good idea to also track the altitude. You're probably even going to want to maybe track like vitals in general, just metrics like, I don't know if it's like CPU utilization, but like maybe the temperature of your missile, the temperature of the CPUs on it. Well, so then you would even know if your missile fails, if your missile explodes and doesn't hit its target, you would maybe want to track some vitals for understanding like why it didn't hit its target. You would want to be able to do some debugging of some stuff that's failing in prod is what the vitals are here. So you'd have some records looking like that. And then you're going to have the history of the latitude, longitude, and altitude in order to calculate its current speed and trajectory towards its intended target. It'll also probably want to have the intended target like given to it prior to being sent up into the sky, into the air, like before being, first launch. You'll need to figure out what the target is. I feel like you'd probably still also have an altitude for where the target is, but all this is kind of like hard-coded information. As opposed to the stuff at the top, which are like logs, or we'll call them like logs. And then we can talk about the data that we're going to want to have in the missile tracking service, which I think is going to kind of have, it's just going to be feeding that straight into the data store. Okay, and we can talk about the schema of this. This is where you're really going to want to know the missile ID. And you might even have the target in a different table that you might record prior to. You might want to make sure that you actually record exactly the target and the missile paired with it prior to giving it the thumbs up for actually launching out of the silo that it's located in. And then these are the tracking records. This could be like you could have this like launch table. Okay, and so I guess I don't know if you would even need a partitioning table. I don't know if it's really going to be getting fed data that quickly. If anything, for a primary key, you're probably going to have something that consists of these two records for the primary key. I don't know if I don't think you're going to be launching missiles frequently enough that you would really need to worry about this, but for like an access pattern, you would probably prefer that this is the partitioning key. I don't think it's going to be firing off 10,000 records per second for a single missile. So it's probably going to be fine for that. For fast reads, I mean, you're obviously going to want that as the partitioning key. But it's like the availability for those writes is really important here. You are really going to care about making sure that those write operations are getting recorded. You might be fine with eventual consistency. It's that so there's this thing called the rum conjecture. It doesn't even have a it doesn't even have a page on Wikipedia. I actually did kind of want to write it myself. You can find it in database internals by Alex Petrov, and it's kind of like cap theorem but for your write and read latencies. You basically have to, all it kind of says is that there's a trade-off between read and write latency. Otherwise, you can kind of get both by making a trade-off of your memory. So R is for read, U is for update, which is write, and then it's memory. So you can also kind of have both by just being inefficient with your memory. But I'm focused on this, and so when you're doing that partitioning key, it's kind of for an efficiency of the reads, but you want to keep really high availability of the writes here. It's really important that you don't drop a single write operation here, and you basically just want to have a write ahead log. And so you might even want to just go ahead and have Kafka, which is just a write ahead log on its own. It's just a write ahead log turned into a data store. So that could even be a valid approach. I guess, okay, so I guess we do kind of have two approaches here. So we're going to go ahead and get rid of this. We're going to call that approach 1. There's a quote, there's a really famous quote. Somebody once said that a database is just a write-ahead log with a materialized view. So when you have that materialized view, that is improving the read times. And we really want to care about that write-ahead log and just the write-ahead log. We don't care about making sure that we're getting consistent read so much as capturing those write operations. So it's I'm going to call this approach 1. I don't even know if that's really all that naive, though. I have no idea. I've asked this before, actually, is whether or not Kafka would actually improve the whether or not it would actually improve the availability of Cassandra on when it has a setting where it's eventual consistency. And Cassandra's leader. Oh, that's what you would want here. Oh, okay. You would probably want to have Cassandra as your database. Yeah. You'd probably want to have Cassandra for your database here because it's leaderless as opposed to DynamoDB, which is single leader. So the advantage of Cassandra here is that there's multiple nodes that can accept the write operation, and so you just care about making sure that the very first one captures that write, and then it's like as soon as you get that back. Yeah. Alternatively, though, you have Kafka, and then you can go ahead and just have, like, I don't know, DynamoDB or something over here. And then your write-ahead log is just Kafka. I don't know if Kafka is really going to make that big of a difference, though. And then it's UDP over here anyway, so it's like even if you don't persist the record, you drop it somehow, and you have like a 5.0x return back to the missile tracking service. It's like, what are you going to do? Tell the missile to send the data again? Not really, not really. And so again, that's why I was thinking that the UDP packet is maybe going to want to rebroadcast like the last 5 records every single time. I can draw that out in a minute here. I should probably look through the chat for anything that you guys have. Yeah, that's fair. Where's the service which invokes the missile based on some signal? Yeah, okay, that's a fair, that is definitely a fair ask. Is that we didn't talk as much about the launch process. So I can maybe do that first, and then we can maybe talk about the repeated records and fully writing out how that's going to work. Yeah, okay, so we have the missile. Let's go ahead and also label this as approach 2. I didn't draw it out, but you're technically going to need some task runners for the data store over there. And then you're going to persist it over to whatever the heck data store that you're using. Okay, so you have the missile, and you're going to need to have some kind of thing. It's going to be the missile launch service. Okay, you're going to have the missile, and it's going to send this signal over the missile to go ahead and launch somehow. And this is what we're going to want to fill out a bit more. And I guess maybe you're going to have some kind of like military guy that has probably not in his browser. It might be some kind of weird desktop application. And he's going to give a signal to launch a missile. It could even be, I think the US president has some kind of nuclear missile button. I don't think that, so when I envision this nuclear missile button that the president has, I don't imagine him typing in a latitude and longitude for the nuclear missile. I imagine maybe some other guy, off somewhere else, has already provided coordinates for where it's going to go, and they just need it authorized by the US president. And then they type in their nuclear launch codes, and then they slap this big red button, and then it fires off a nuclear missile. We're not talking about a nuclear missile today, though. We're talking about ICBMs, and so I don't think it would be the president's big red button. I think it's some guy at a desktop app that's just going to do some kind of thing on a computer screen, and it'll have some kind of latitude and longitude, maybe an altitude of the location, and it's going to give that to the missile. And then, okay, so probably have that in advance, and then maybe there's like a path that it already traces out in advance for how it's going to go. And then it hands that all off to the missile, make sure that everything's all clear with it, and then it's going to try and get out of the silo after it's done this like pre-computation work prior to the launch. Missile connected to missile launch service. Yeah, right. So that's how I'm trying to. Okay. It's going to do some kind of. So this thing is going to hand some information over to, this thing's like a smart device. This thing's kind of like a smart device, like those smart sensors from the weather app design, or like the vending machines. So there's going to be some kind of call from this to the missile. It should also log some stuff prior to the missile getting past some information, and then it's probably going to log that it finished passing off the information. And then maybe this thing's also going to give some information right before the launch saying, hey, I'm launching off now. Well, that would, so when it's saying I'm launching off now, that would kind of be one of the UDP signals, like this one. It's like, I don't care if you tell me 200 okay or not, or 503 or whatever the heck it is. I'm heading out of the silo right now. So that would be the first UDP packet is, hey, I'm launching. So you could even have some kind of status field on the log that's handing over to the backend is launching or in progress, or malfunction or something could be part of the UDP packet over here. And so that one would be one way. And again, we're probably going to be logging some stuff. So I mentioned a second table of a launch table. So we're maybe going to have some kind of launch table for the missile ID. And again, could probably have status there as part of it. Or even, that could even just be a log field, its status, or info or something. I guess we can just go ahead and leave it as status. Okay. So we have some kind of thing. It's going to tell the missile launch service, hey, go ahead and do that thing. And then it's going to go ahead and record it to the data store. It's going to tell the missile to launch. It's probably going to log again after it's done, telling the missile, hey, you need to leave the silo. And then we'd start getting our launching malfunction thing. I guess if you get a malfunction thing back, it's saying, hey, I can't leave the silo, then the missile launch service will have to pick a different missile to have launched at the target, perhaps. I'm noticing this has some partial failure scenarios to it, and then like, what if the power gets cycled on this in the middle of trying to launch a missile? So then that would probably be a pretty bad partial failure scenario. We probably want to do something in order to make this a little bit easier to redrive. So let me go ahead and label this, and then we're going to try an alternative approach. So launch process approach 1. And then we're going to do launch process approach 2. Welcome. Thanks for joining. Oh, how is missile connected? Yes, that's what I'm currently working on. What if the destination is another missile which is also moving at supersonic speed? Oh, a reactionary thing, a fully automated system. Yeah, okay. That would... We can do that as a second variation. Yeah, we can do that as another variation. I think I'd maybe say it would be a fair assumption in an actual interview to say that's out of scope, because that's going to be quite complex, but that would be a fun extra variation to cover, and we can do that next. But yeah, I want to try and make this a little bit more resilient here. Okay, so we're gonna maybe just go ahead and capture it on this worker thing. That'd be a rather slow reaction time. It would add an extra 100 milliseconds to the latency. But if it's like an ICBM or some kind of crap that relies on like the president to hit a button, you you aren't really going to care as much about a 100 millisecond latency getting added. But that's just something to note, is like, hey, this broker is going to add a little bit on the end-to-end latency for the launch process. And then even the launch itself, for one of those things that's getting fired out of a silo, I mean, of course, it's going to maybe pick up speed pretty quick, but it's a several minute journey if it's going to be going thousands of miles. I think 100 milliseconds is not going to be the worst thing in the world. And then you're going to have, maybe it's not a missile launch service, maybe it's a missile launch worker. And then since it's low volume, it's just provisioned, it's a permanently provisioned thing that's always pulling this 24/7, just, I don't know, a couple of machines for redundancy. It's just continuously polling this thing. And then it has this whole thing that's going to do if it ever picks up on a message. It would log to the, we had a name for this. It was the launch table. We can call it the launch status table. Or logging. I guess logging is probably the most accurate way to describe it. Okay, so you're going to log right before the launch. You can go ahead and tell the missile, hey, go ahead and do it. And then you're going to log afterwards. This is similar to the whole, what I had said about, what is it? Like email sending, where you have one, you can't guarantee exactly once delivery. You can only do at least once. Oh, you know what? Maybe you can use the auth capture flow here. Yeah, maybe you can go ahead and use the auth capture flow. So you would go ahead and retry this, the passing off information for a given launch scenario. So you're loading the information on, and then you would give it the calls for, hey, go ahead and do the actual send off thing. So the first one is just like, hey, this is a launch event that we want to do. Please hold this information on your devices, your internal components. Load up the information for your components. Go ahead and leave the silo in the second step. So just like the auth capture flow, you can go ahead and add that as another resource. Okay, so then you would do the actual launching, and then after you do that second step, you would go ahead and start receiving your UDP stuff to a missile tracking service. And it's probably going to be a little bit lower level than UDP, but the concept behind whatever's going on here is going to be UDP rather than a TCP handshake with every request. Let's go ahead and give this a somewhat nicer label to really describe what's happening here. Okay, and then if you get a malfunction here, you can actually retry after that step 3. Okay, so there's 2 things that I wanted to do here. One was that I didn't actually dig into something over here, and then the second one was the Iron Dome style thing. Let me write that down. So 2 Iron Dome style variation. I see your comment. I'll get back to that before I get into these other things. What did I want to fill out more? Oh, it was these. Yeah, I wanted to go through these since it's UDP, and so you're not actually confirming whether any packet was received. So you'd have something like packet number 3, and it would actually be just like this list of log mint 2, 3, 4, and 5, and then you would have packet number 4 has 3, 4, 5, 6. So then every single time that there's another log that you're wanting to broadcast or another batch of it, you're covering several of the previous ones. It's doing some redundant sends of old information. You could also have the missile tracking service telling it an offset, or doing something similar to whatever the torrenting services do. Like, hey, I didn't get this chunk of data that I thought you were supposed to send like a minute ago. I think this approach is maybe a little bit more realistic than that, though. I don't think you would really be wasting much time with trying to get old information from the missile. But that was the thing that I wanted to provide more information on. You wanted the Iron Dome style thing. First, I'm going to get back to, is the traffic encrypted? That's a good question. I think you wouldn't want to be broadcasting your location updates from your missile, because that would make it a lot more easy than if the enemy were to just use radar to try and figure out where the missile is. If you're actually broadcasting your own location data in clear text, so you would probably have it in UDP, but encrypted, and okay. So you would need to do some kind of load of some kind of a key exchange prior to the launch of the missile. So I think you would probably want to do a key exchange somewhere in here. While it still is in the silo. And since that should be in a controlled environment, maybe you can even have a physical wire running directly to the missile, so that it doesn't actually have to send anything over the air within that controlled facility. It'd be a controlled facility, though. Maybe you'd even have special keys put onto the missile while it's being made, but it should have some kind of private key or signed certificate installed on it at some point. So that's a great call out, though, that I do think that you'd probably want to have it encrypted, since you don't want to have the enemy just going ahead and getting the location data completely for free. That does seem a little bit ridiculous. Great call out with that. Okay. You actually probably wouldn't want to put off some key handshake all the way to the launch process. You'd probably want to have that happen like a good, you know, time beforehand. Although I guess if you're leaving that kind of data sitting around for a while, you know, it's like you can be giving the enemy time for crunching the numbers on, you know, whatever your private key actually is. So maybe you wouldn't want to have that kind of private key information sitting around for a while, since like you can brute force stuff over time. And given that your enemy is a state, it's a nation state, they're going to be willing to throw, you know, a whole army of thousands of computers into trying to crunch whatever your private key is, of course. So maybe you would go ahead and put that off until the actual launch event. Okay, somebody did want the Iron Dome. I can get to that. How is missile communicating with service while in flight? What network is it using? So we have talked about that a little bit. Is it's going to be something a little bit similar to UDP style communication, where it's one way and you're not actually doing a back and forth handshake between the missile and whatever tracking service. I mean, it's not like the missile has Wi-Fi access. That's a great call out, but it'd be UDP style connection. It would maybe use, it could even use a radio frequency broadcasting thing. It might not even be a 1 and 0 style communication that they're doing, but a radio frequency being broadcast off the missile. But it's the emphasis here is that it's one-way communication. You're not really trying to hear back from the missile tracking service, or doing like the two-way handshake for normal network traffic. Okay, Iron Dome. Iron Dome. We want to handle this Iron Dome thing. Okay, so the launch process is going to be different. It needs to be more automated, more reactive. Okay, so you're going to have, let's say that there is the missile launch service, but it's not going to be triggered by a person. We're going to call this the Iron Dome variation. Okay, you're not going to have the browser. So, like, you're going to have some kind of thing continuously monitoring for... this is going to be like the weather app problem. It's going to be like the weather app problem. You're going to have the... what is it? Monitoring workers, radar workers, sure, radar workers, sonar workers, radar workers. They are continuously, they have some kind of thing that is sending out these signals and then trying to figure out whether or not they have picked up on, maybe it's LiDAR. It could be like a LiDAR system. Like, hey, is there something in the sky? And is it supposed to be there? So you'd maybe even want to know if there's airplanes. Is there, so like you see something in the sky, you would probably kind of try to figure out the size of it, which you can use from LiDAR. It's like depending on how far apart, how far away the response back is, and then the angle between the leftmost and rightmost point of that object, you'd be able to figure out the size, and then it's like whether it's a bird or whether it's something quite larger, like a whole plane. Well, okay, I guess as opposed to a rocket's probably, it's not going to be that much bigger than like an eagle or something, but it's going to be moving rather fast. But LiDAR might work there for the radar workers. So it's going to be continuously looking for some kind of object in the sky. Oh, it's going to be needing to log the location of that thing in the sky and predicting where it is in order to tell the missile to go hit that spot. okay, so you're going to kind of need some logs on the radar workers. It's maybe just, okay, so you'll have a bunch of radar devices. You can have a bunch of radar devices. We're going to go ahead and use this. So let's say you have 3 different devices probing the sky for rockets. And we're just going to say that this is how we're kind of showing that LiDAR signal. It's not actually communicating with anything. Well, it's like it's not really a communication style. It's a communication style in the same manner that you would maybe be trying to figure out how far away a rock is. You send a signal at it and it bounces back off the rock, except instead of a rock, it's a rocket. That's what's going on there. And you would log that position, so you would maybe see something over there, and then you would maybe see it over here. So you need to log the position at point A and point B, and each one's going to be doing that. So I guess you would probably need to keep those logs on the machine. You'd probably hold it in RAM. I mean, it needs to react really fast here. So it might even just hold the logs in RAM. And we'd probably want to have some redundant devices here. So we have a whole bunch of devices doing that. And I don't know what the hit rate is of them. So I mean, if each one goes ahead and says, oh, I see a rocket, and then all 3 launch off a rocket in response to that rocket. And then I guess the launch service is kind of like it's like, I'm thinking of the word sidecar deployed with the missile launch service and the missile itself. They are all on the same device. They're not actually going to be communicating over an internet connection, because the missile and the radar system, I think, are attached for whatever it is that they're using over for the Iron Dome. So it's going to look a little bit more like the stock exchange thing, and you're using like mmap. But those are all going to be like on the same device. I don't know if the CPUs really have so much onboard guidance for that. That's really interesting. I think it is using something a little bit more like mmap though. And these I really feel would probably be in RAM. I want to draw these a little bit more in that sidecar deployed manner. Okay, and we can draw it a little bit more like this, and we can just throw the word mmap on there. Yeah, all right. I'm pretty happy with that. It should be on one device though. I don't know if there was anything else I wanted to cover on this. I'm pretty happy with this coverage. Yeah, okay. I guess, oh, you know what? I should give you guys the file before I drop off. Okay, so here it is right here in the chat. I didn't give you guys the Discord link. I'm sorry about that. I need to do that as well before I drop off. I'm going to edit the description of the video first. I never turned off the 9:15 a.m. getting started message. I just noticed that. That's wild. There, now it's gone. Okay, I'm trying to edit the description of the video with an Excalibur link prior to ending this thing. Okay. There. Okay, it should be in there if you refresh the page. Okay. Yeah, thanks for joining. I hope this was fun. I'll try to do 9 a.m. For at least the next couple weeks, probably, because I want to make sure that I still have at least one India friendly time. And again, I'll have another stream this afternoon at 3 p.m., which should be a lot more friendly with PST, maybe London time as well. Thanks again for joining me. I'll let you guys go. Yeah, see you next time. Thanks.